Welcome to the third Digital Analytics Meetup this year. Again, live streamed directly to you from our office. My name is Marco and I organize these events together with my colleague Cosima. And yeah, actually, I've been organizing these events for quite a while. I think it's already 5 years by now. And yeah, I think it's gonna be a really cool session today with Richard from SAP, who will be tuning in live from Ireland. I hope this works all out. I think it's the first Berlin Digital Analytics Meetup where we actually have somebody dial in from far away. Usually, I mean, this event is very much centered around Berlin and the Berlin community. So I think it's especially cool today that we have with this situation the opportunity to also get somebody in from further away. Please do use the chat. As always, we will answer your questions and we're very happy to enter into discussion with you. Richard will be there after his talk to answer questions, to also hear your opinions, obviously. So please do use the chat feature on YouTube. We will be monitoring that very closely. And yeah, that's it from my side. Without further ado, I'll hand over to Richard. Really cool to have you here, Richard.
Perfect. Thanks very much. Can you hear me?
Yes, we can.
Excellent. I'm just going to share my screen now, and thanks very much. It's the first time I've ever been privileged to be part of the Berlin community, which is something that I've aspired to for many years. Any type of Berlin community. I hope that everybody can hear me well, and I hope that you can understand my accent, which being from the very center of Ireland, we do not tend to pronounce our words properly a lot of the time. So I'm going to do my best on that. I guess the topic that I wanted to do today is your data is fooling you, and really it's about thinking about all of the different ways that your data can fool you. And when I was thinking about this presentation, it reminded me of a Twitter account that I followed called The Bear. And the bear tweets about his life being a bear and how he gets shouted at by humans when he goes after perfectly acceptable foodstuffs, about the various things that happen to his fur and how he's always a little bit scared, at least. And I feel that way about this presentation, that effectively I'm not going to do a corporate presentation by any manner of means. And like I'm a product manager, I'm not a data scientist. So I'm straying a little out of my comfort patch, but also I want to always be at least a little provocative and to say things which, based on my learning from working in the data world for the last couple of years, is true. And I thought that this was an interesting way to kick off the presentation. It's a fabulous Twitter account as well, if you're ever interested in going to it. The other key thing about this is I work for SAP, but really I didn't want this to be a corporate sales pitch or a corporate presentation. So I've taken out all of the branding, and I've really kept down the amount of, I've kept some images that I would use in my normal presentations if I was doing some type of pitch. But really, this is meant to be notes from the front line. The views and the opinions are my own. And I wanted it to be a little bit more type of informal than what you would normally have for a presentation, because it is a meetup. I wish I was there in person. I wish everyone else was here in person as well. In terms of the agenda, if we think about this as an informal agenda, I'll talk a bit about predictive analytics, data science, machine learning, artificial intelligence for business users, and overall, how do we democratize data science? How do we democratize data? I will talk a little bit about some of the lessons that I've learned. I'll give some of my opinions about what we should be doing. And I'll also talk about things that currently we're excited about in SAP in the area of predictive analytics. But as well as that, when I do that, I will bring the other meaning of an agenda into the presentation, which is like, how do my company, how does my product line see the use of predictive analytics, the use of data science for business users over the next couple of years? So one of the big themes that we see in BI and analytics at the moment is that if we think about maybe a standard type of chart, and we put the amount of data massively increasing on the y-axis, and then the type of expectations in terms of both the speed of insight and the depth of expertise required on the x-axis. And then we think about the last, say, 30 years as a transition from the semantic layer that was almost entirely IT driven, where effectively everything in terms of reporting and business intelligence that a business user saw was very much like stuff that had been put together by an IT organization for their consumption in order to help them understand the business. And then in the last like 10, 15 years, we started to move very much to a business analyst-driven paradigm, where the primary method of understanding data was through visual data discovery. And what most people in the industry are now agreed on is that the next wave of analytics is going to be driven by augmented analytics or driven by machine learning. And there's a number of different reasons for this, but primarily it comes down to two drivers. Firstly, the amount of data that's been generated has actually exceeded the cognitive ability of people to be able to understand it and to be able to make meaningful sense of the relationships between it. And at the same time, there's a massive executive and corporate expectation that as a result of this data, we should be able to have much faster, better insights, and that these insights should be delivered directly to business users with very, very low expertise required. So you should have some type of democratization of analytics as a result of it. So the big challenge with this is like effectively up until now, these two worlds, machine learning, data science, and BI analytics are very different. The data structures that they sit on top of are very different. And actually bringing these two worlds together is quite hard because like all of the type of structures that are in place on the BI world have been put in place in order to make sure the data is clean, in order to make sure you've got governance, in order to make sure that you're looking at the correct type of business data to answer your question at any given time. Whereas data science and machine learning data structures tend to work on very different type of flattened data sets. The more data you have, the better it is. And the type of, when you need more data, it means that, the person who's looking at that data has to have access rights to a lot of that data. And so bringing these two together is hard, but not doing it is chaotic and ungovernable. Because what we can't have is like, the traditional governance data on the left-hand side that like we have entire control over, we have entire governance on, we trust everything. And then on the right-hand side, we've got like entirely flattened data set that has all the data of the company all in one place, sitting on somebody's hard drive where it's being executed on by a Python program. So one of the big challenges that we have as we go through this next wave of BI is figuring out how to bring together the BI and data science structures and the BI and data science worlds in order to maintain your governance, maintain your security, maintain your trust in the data, but at the same time, be able to take advantage of all of the algorithms that are coming out there. So ultimately, from our perspective, context is everything. So if you understand the level at which a person asks a business question, you understand what their role is, then it should be possible for you to be able to flatten data in such a way that it can use machine learning in order to be able to answer the business question. And if we're able to do that while maintaining the trust and the security, then that is an incredibly powerful thing to do. And really, when we think about this, about what keeps us up at night, it's how do we bring these two worlds together so that we can use the context that's available within our BI dashboards and our stories in ways that allows us to be able to reuse the data structures that we have, but at the same time to be able to take advantage of machine learning and algorithms. The other key thing that's really important is explainability. And that is that to a large degree, you can point a machine learning algorithm at a business problem or at a set of data, and it can give very, very different answers to the type of question that you're asking it based on very subtle differences in the data, like the order of the data. It can give very different answers based on like whether or not you've got 50 columns versus 100 columns. And so actually explaining to a business user how these different answers can be simultaneously true and enabling them to interpret the output of a machine learning algorithm in a way that doesn't fool them is actually the most important and powerful thing that we can do. And I think that this is still a journey that we're on, that we're working at. I think this is both true whether you use a data science workbench or a data science platform to be able to do the analysis, or whether you do it using one of these type of really snazzy UX or UI driven tools. And helping a business user to be able to interpret that in a way that doesn't fool them is one of the most important things for us. And so when we think about BI in this new era, we think that what we're actually doing is rethinking analytics with intelligent augmentation. And by that, we mean if we take the left-hand side of the screen, we can see the type of capability conversational analytics, conversational AI, natural language generation to explain things, alerting based on data-driven alerting, prescriptive analytics, so what should I do next, machine learning, interesting points of interest, all of that type of thing. And so a key point about that, what we do within our product lines is we figure out how to adapt this intelligence to the left-hand side of the screen. So, what is an appropriate algorithm? What is an appropriate workflow or use case to surface to a user when they're doing planning? What's an appropriate use case or what's an appropriate capability to surface to somebody when they're doing data discovery? What's an appropriate capability to surface to somebody when they're doing visualization? And in almost all of these cases, they're going to be somewhat different. So for data discovery, automated explanation is a natural understanding, a natural fit. Visualization, automated insights is a good fit. Predictive and planning, we'll talk about in a couple of minutes. But ultimately, bringing together these two worlds is all about rethinking these workflows and rethinking analytics. Another really interesting type of concept that we have is this kind of like a lot of vendors and a lot of companies, including our own, are taking the same set of data, running it through a number of different algorithms in parallel, and then based on the outcome of these algorithms, making a decision as to what's going to be the best result. And in doing so effectively, they're stacking up algorithms in order to be able to answer business questions. And I stole this from the internet, but I thought the whole vegetable metaphor was an excellent metaphor for explaining this. But the key problem with this is it's a beautiful idea, but ultimately, if we're all agreed that like over 70% of the work of data science and machine learning is data preparation, then automating the stacking of algorithms is only going to create less than 30% of the effort or solve less than 30% of the effort. It looks really impressive, but it doesn't really address our problem wholly. The other key point is it assumes that algorithms behave the exact same way and, with a single configuration are capable of coming out with the right answer. And in my experience, that's not entirely true. A huge amount of the work that gets done here to generalize these capabilities is going to be different on an algorithm by algorithm basis. The other key thing as well is that model results is normally improved through better data preparation, thinking about time horizons, thinking about hierarchies. And therefore, as data width increases, we're going to get better results. But a lot of the things that we need to be thinking about is data lineage, like our confidence in the data, especially if it's highly automated. We've been working with various different vendors that give us access to a huge amount of data. And actually, what we've often found is that if we widen the data substantially, so if we go from hundreds of columns of data in a data set towards thousands or tens of thousands of columns, the overall model accuracy will improve substantially. But then if we dig into some of the variables that we've used in order to build our predictive model, what we've often found is that effectively not all of the variables stand up to scrutiny in terms of, well, what is that actual column? What does it mean? And is it actually accurate? And should it be relevant now? So it doesn't stand up to business user scrutiny once you've got a better model. And the other key thing as well is that if we're really talking about citizen data science, one of the biggest challenges that we have is that effectively it's very difficult for business users or citizen data scientists to understand things like the predictive process, the difference between training and apply. The fact that the training window is 30 days before the apply window, the fact that you have to be worried about how that data changes through that window. And so the algorithms appear on the surface to be really complicated, but the actual thing that people struggle most to understand is the actual predictive process of how do you go from having a training data set through to an apply data set, and how do you maintain that over time as data changes. And that's the operationalization of the predictive process is one of the trickiest things to do. And then that also comes down to, like, if you've a non-operationalized, non-explainable, and most of our type of mental and cognitive thinking has hidden bias, you can get to a situation where you can keep playing with the data, keep playing with the models until you find the result that you want. And as a result of that, is decision making improving as data increases? And that's something that is one of the big problems that we're going to have to solve in the next couple of years. And then finally, at the moment, XGBoost is normally the best algorithm that we found for answering these particular questions. And so if we stack up all of these algorithms on top of one another, but the answer and the algorithm that wins is almost always the same, then it just means that we're wasting electricity in doing this type of massive effort. So it's a question really, and we know that broccoli is always good for us as well. So it's the type of thing that ultimately we believe that the thing that's going to make the biggest impact to this type of environment is improving the data preparation, improving the trustability, and making sure that people can answer and interpret the answer that comes back to them in a sensible way. So the type of thing that's making us really excited at the moment in terms of predictive capabilities is in the intersection of predictive and planning. And specifically, what we found is that a huge amount of business users and predict
Seems like Richard just froze. We're trying to get him back in. Probably his connection was bad. I'll just try to get him back in. Don't know any funny jokes right now, so probably won't be able to bridge that. I'll rather try getting him back on the line.
So, Marco? Oh, thanks very much. Yeah, I heard the beep, so I guessed that there was something wrong. So apologies.
No worries, you're back in.
Excellent. So we made it feel like a real digital meetup.
Exactly.
Cool. So ultimately, what we're seeing is that there's two areas mainly that is really interesting in terms of predictive and planning. One is in the area of predictive forecasting, and the other is in the area of strategic analytics. And these is some of the simplest ways that we can introduce predictive to business users in ways that really make sense to them and that is easy for them to understand. And specifically, the type of thing that we're talking about here is really historical data, machine learning plus business acumen equals confident planning. And ultimately, the interesting thing about this is that the predictive forecasting, what it really does is it automates the creation of baseline planning models. So it's not really interested in the type of really accurate forecasting of the future. It's more concerned with time-saving mechanism in order to enable a planning model to be created very quickly. And then the planners can use their business acumen to supplement the forecasts to make them more accurate or in order to reflect type of business usage. And then afterwards, they can monitor the plan attainment based on continuous updated predictions. So there's two parts to the process. One is the creation of the baseline, and then the second is monitoring the attainment based on updated predictions afterwards. And so, like, the other interesting thing about this is that, you know, you can do this from both a top-down level. So you can say, I'll go to the top of my planning hierarchy, I'll forecast for that. Or you can also forecast from a bottom-up perspective. So you can say, right, I want to forecast for every product in every region to be generated automatically and put into the plan. Now, the interesting thing for us when we did this is that really the simplest model is sometimes the best. So actually, like, you know, we can do time series forecasting where effectively we build a time series forecast and we include influencers on that forecast. So we use extra predictor variables that is going to enable us to have a more accurate forecast. But actually, for business users, trying to get extra predictor variables on future values needs future values. And if you don't have those future values available, then you have to estimate them. So it automatically creates inaccuracies in the predictive values. Now, it's possible for us to try and overcome that by effectively having some type of time lag mechanism on the future values when we use them as being influencers. But that then becomes complicated for the planner to understand. And so what we found is that a lot of people are interested in using key influencers on future values, but almost always what people eventually do is they use the simplest model. And the other thing as well is that a lot of times you really have to explain to business users the difference versus a formula versus a predictor. Because ultimately, like if you know that your unit sales are going to be entirely predicted by the number of units multiplied by the unit cost, that's entirely useless to you in that situation. Because ultimately what you're trying to predict is what are the unit sales going to be. So removing formulas from the equation, keeping it very simple, keeping it just at a high level business number is important. The other really interesting thing is that a lot of business users, what actually happens is that instead of experimenting with algorithms, what they started doing is experimenting with hierarchies. So they start thinking about like how much, should I predict at the region level? Should I predict at a country level? Should I predict at a worldwide level? And do I do it by product line? Do I do it by business unit? And that is quite complex in that, it normally has a huge amount of dependency of the volume that you're selling in a unit, in a region. So if you have an extremely low volume product, the predictive algorithm is not going to work. If it's a high volume, it probably will, because the volume will help smooth it out. So experimenting with hierarchies and to figure out which is the right level for you to predict at, and experimenting on time horizons. So like, it's very unlikely you're going to be able to predict 2 years in advance. Maybe predicting a month in advance, 6 months in advance is better. So ultimately, these are the type of experiments that business users have. The other key thing is that people want to use predictive to do non-predictive things. So they want to say, right, well, I can see what COVID-19 in China is. How does that impact COVID-19 in Germany? But the type of the background, the data associated with it, the conditions, the healthcare systems, everything is different. So an algorithm is not going to help you there. What you have to do in that type of situation is some type of simulation, some type of business modeling in order to do it. So helping people with real world type of understanding, real world decks to help people to understand this is very important. And as I said earlier, predictive is about automation as well as predictions. So like automating algorithms or automating data preparation, it helps, but it's actually the automation of the planning process in this case is what we're doing. And so it's not so much about forecasting or predicting the future. It's really about the type of automation that we can do and how we can reduce labor and how we can reduce effort. So what I wanted to do, sitting within the time window, this has been some fairly random ideas, a little bit of type of opinions, a little bit of understanding of what people are talking about and understanding of what my own experience has told me. I wanted at the end to get to the point about the presentation. I wanted to find a nice visual about getting to the point. So I actually did a Google search for getting to the point, and it told me that the point is actually a location somewhere in Brannan Street in San Francisco. And it seems to think that I'm located in San Jose, even though I'm based in Kilkenny, which is probably something to do with my VPN. But it really felt like it was a good summing up for me of a presentation that said that my data is definitely fooling me. But ultimately, the key questions that I had were like, have you read Thinking Fast and Slow? Do you understand cognitive bias? Can you avoid its consequences? And can you say the same for everyone you work with? I always remember that when I worked in sales, some of the highest performing regions in a quarter were always the smallest regions. So effectively, you would look at a European dashboard and it would have Germany, France, and Ireland would do really well or really badly. And so everyone would say, let's figure out what Ireland is doing and let's figure out how to do that. But the actual fact was Ireland was a much smaller region. There's a law of big numbers which introduces a bias on small regions. And as a result of that, we were all interpreting the data the wrong way. You can get a machine learning algorithm, you can get your data to tell you any story that you wanted to tell you. But unless you really, really think about it from a neutral perspective, ultimately what you're doing is weaponizing data. What you're doing is using it to help you with an argument rather than using it to really learn from your business. Another one that's important to understand is Simpson's paradox, how you can get multiple different closely related answers to a single business question that effectively, when you're using algorithms, and how a change in one piece of data can have an impact on another piece of data. And so it's not possible to use them independently. And so we need to be very, very careful when we apply machine learning to data that we take these type of things into account. And then finally, and most importantly, do you know the lineage and build of every single data point used to drive your decisions? Because ultimately, the outcome of a predictive model, the outcome of a machine learning model is only as good as the actual data which is used to drive it. And that data has to be continuously updated on an ongoing basis and has to be maintained up to date and has to be accurate. And as a result of that, like, it's very, very tricky to be able to do that in a really scalable way. So this is what I had today. So do we have any questions? And hopefully visuals in people's videos. It feels a bit able to see anything.
I can imagine, but you did a really, really good job. Thank you very much. That was super interesting.
Cool.
Good. I'm gonna check if we have any questions from the audience. If not, I do have some questions already. I already say sorry. I'm not a data scientist, so if my questions are stupid, please do excuse Richard. So I was wondering, because in the very beginning you said that you would the data needs to be flattened, and I was wondering, I mean, before data science was really big, we didn't flatten the data, right? We were mostly also working with much more structured data in a way. What are the advantages now, and why is that even needed for those data science applications?
So you need to figure out, like, ultimately, the direction that we're probably going in is a direction to which, you know, you have two different types of data structure. One is for data science questions, the other is for type of classic BI questions. And they're probably going off the same data source and probably in some way virtualized data structures on top of them, so that you're not maintaining multiple different copies of the data. And so when we think of a flattened data, what we think about is like effectively bringing the data down to a level where the data density is at as enough type of capability in order to be able to answer a business question using a machine learning algorithm. So, like, if we think of the opposite to flattening, we could think of it as being a hierarchy where you've got the sales for North America and for Germany. And if you think about at the bottom of the hierarchy, you've got like all of the transactions which make up that data. Now, neither of those structures are going to answer the business question very well. The transactions at the bottom of the hierarchy are too narrow. They probably have maybe 4 or 5 columns. The transactions at the top of the hierarchy are also too narrow, and there's too few of them. Like, there's only, you know, maybe 20 regions that you're going to have your sales on. So really, you know, the type of entity that you flatten around is probably where the data density of your business is going to be the greatest. So if you're a business-to-business organization, it's going to be something like opportunities or accounts, because you'll have a lot of data around opportunities and accounts. And so an individual account would be SAP, and you would have, you know, the total number of employees, the founding date, how many times do you meet them a year, how many products do they use, etc. And the more columns that you have, the wider the data set goes, and the more likely it is that you're going to get an accurate predictive model. Now, that would be for opportunity data in B2B. If you're talking about an HR business question, which has its own data privacy problems, you're probably talking about employee data. If you're talking about a supply chain question, you're talking about supplier or product related data. If you're talking about some type of B2C CRM, like an Amazon or Zalando type business question, then you're probably talking about consumer related data. So, you know, how much is my consumer spending with me per week, per month? How many transactions did they do? When did they spend the transactions? And the second thing then on a flattened data set is you probably have an awful lot of time related questions in the derived variables. So if you just take a CRM and you flatten it down to like the consumer level, you just have the data at a point in time. For really flattened data to be useful, you need to what is the change in the consumer's behavior over the last 30 days, 60 days, 6 months, 1 year? Are they starting to increase the amount of time they spend with us? Are they starting to reduce the amount of time they spend with us? And so the type of the data structure becomes very, very different once you start to derive those variables. Hopefully that made sense and answered your question.
Thank you very much. It did. We actually have a question from the audience. Actually, from two people asked at once, from Dominic Brown and from DJ Lupo. How do you actually create this kind of data literacy in your staff? Or how do you deal with the stakeholders who have themselves difficulties with these topics? And Dominic says, yeah, and in my experience, there are many of those, which is something that we can totally relate to from our practical experience. So definitely also curious to hear what's your take on that.
Oh, if only we had 24 hours. I think on data literacy, like I think that there's a hunger from organizations to extract value from data. And the thing that we always taught about data fooling you is that your data can only fool you for so long before you get very angry because you made a business decision. And if you make a business decision based on data and it turns out to be incorrectly analyzed and you interpreted it in the wrong way, then it's a very strong way of correcting that. And I've absolutely no doubt that you'll have that Gartner curve of, in every organization of where everyone gets excited, then everyone gets upset, and then finally everyone becomes enlightened as well. And I think that the most important thing for stakeholder management is it's such a difficult question at so many different levels, is to really take the time on the first projects to get it right and not to allow your data to fool you. And if that means being a bit slower than you would like, being a bit more careful in the type of project that you would like to do, and taking your time both to really make sure that you're doing it properly and to really make sure that you're going to get the results that you're doing, and being quite everybody wants to chase predictive maintenance. They all want to know they want to know when the $10 million machine in Chile that has never failed before is failed, right? And it's almost like everyone wants to deliver a quick win. That we're all searching for El Dorado. You might be better off improving a key business process by 5% and saving X amount of money as a result of it, and then actually creating a culture that incrementally does that across your business, so that the 5% tiny small things add up to a big thing. And that will only be done through being painstaking and taking a lot of effort over it.
Cool.
You had 100 different answers to that question, so that is really my opinion.
I can imagine. Actually, your answer just brought me to the next question that I wanted to ask, because you said that everybody wants to use predictive. You said before that people would use predictive for non-predictive things. How do you avoid that? How do you actually convince the people to use predictive for the right things?
The question then becomes as well, how do you hire the right people to advise you well? All right, because it is very, very easy for all of us to become data scientists quickly, with all types of qualifications, which are various different types of quality, and it really is. I think that understanding where predictive can help and where it can't help, and what type of business question it can be applied to, and whether or not you have the data associated with it. That all comes down to skill and experience and being able to say no, and having a certain level of seniority, and having the knowledge to be able to say, well, actually, I know you want to do this, but we could spend 6 months trying to do this. We could waste a pile of resources and we could make no money out of it. And what I actually think you should do is this thing that doesn't seem as attractive to you, but that could be a potential gold mine for you. And having the confidence to be able to do that is something that's only going to come with skill and experience and real knowledge.
All right. Yeah, do we have more questions from the audience? Please put them in the chat if you have more. If not, I will just use the chance and keep asking my questions. So I will get smarter at least.
And just to follow up on that while we're at it, like I work with a guy called Eric Marcaday who's been doing this for 30 years. And I'm a business guy, I'm not a data scientist. And I'm from a sales background. And the first year that I spent working with Eric was Eric telling me, but Richard, you cannot do that. And I'd say to him, but it makes absolute business sense for me to do that. We have the data, it's all there and be there. No, Richard, you cannot. And I like to think after 5 years, I have a better idea of what I can and cannot do, right? But sometimes I do wonder. Sorry for interrupting you.
No worries, no worries. We actually have another question from Dominic. He says, different topic. What are your thoughts on the use of machine learning on the public sector, social science, and public decision making?
I think it's a tremendous opportunity once the ethical frameworks are in place and the privacy ideas are thought through. And what I mean by it's a tremendous opportunity at a macro level anyway, like for us to make better decisions as a society and to really understand what is driving particular outcomes in a particular way. Like we did a recent study for a Gartner BI bake-off on non-environmental factors in health care outcomes, which really showed the impact of eating bad foods on your life expectancy. And that should be absolutely used to drive healthcare policy. I think there's ethical boundaries that we have to figure out as to if Richard eats an awful lot of chocolate, should Richard get a more expensive healthcare policy? And I don't actually know the answer to that. There's arguments to and fro, but definitely we shouldn't do it without an argument. And then as well as that, there's very, very the level of data that we're able to know about ourselves, both from non-government agencies, commercial entities, and also government organizations, understanding what are the boundaries of private data is going to be hugely, hugely important. And there's arguments in all directions for that. But so I think that's for society to figure out collectively, and that figuring out how to have that conversation in the modern democratic world is going to be interesting.
I can imagine, yeah. Going a bit more into the technical realm and the things that you showed before, you were talking about stacking different algorithms and the dominance of XGBoost in those, which is something that we've obviously also seen. Maybe you could go a bit more into detail why then even again stack algorithms, and how do you actually choose the algorithms that you're going to stack if XGBoost is so dominant? On maybe there might be reasons for actually choosing a different algorithm and choosing a combination, right?
Yeah, it's a point at which at some point my knowledge will be exhausted. But at a high level, XGBoost is one algorithm. I just used it as an example there because it's a particularly good one. There are other ones that, that there are things that we do internally in SAP that do not involve the use of XGBoost. Our core belief in, like, I work for the Analytics Cloud organization. We've got predictive capabilities in Analytics Cloud. And when I talked about predictive and planning, and predictive in BI, I was mainly talking about Analytics Cloud. But so we would believe that you shouldn't stack algorithms unless you're doing it for some type of reason. You might use this, which are reusable, that effectively enable a business user to be able to figure out what's the best result for them, and that protects the business user to the largest possible extent from misinterpreting results. Because ultimately, stacking algorithms, it requires a great deal of expertise to be able to understand what the difference is between the algorithms, and it requires a great deal of expertise to be able to configure them so that they're answering equivalent questions. And so, like, if scientist
Seems like we have another connection problem. I'm gonna get Richard back in quickly. Richard? Richard, you back? Yeah, I can. He's back. But we can't see you yet.
So apologies for that. I'm on my MacBook Pro speakers now.
All right.
We've got the buzzing sound, but we'll get over it.
No worries.
So we decided to do an experiment today. But yeah, I think that, like, if you're providing automated data science tools for business users, you should wrap it up in a way that makes sure that they can't make errors either in the input or the outcomes that they expect to achieve.
All right. Perfect.
Audio problems.
No worries. Don't worry at all. That happens. I think that concludes it anyway. We're already 50 minutes in, and I think we don't have any further questions from the audience. So thank you very much, Richard. That was a really, really insightful talk, and I think it was a really, really interesting answers to all those questions as well. Very nice. Thank you very much.
The questions were very good, and I hope to. I tell you, participating in a Berlin community meeting remotely from Ireland is not half as much fun as meeting you all in person. So,
well, Richard, we hope that we can do that at some point in the near future. You will be definitely invited to our meetups. It would be really, really great to have you in person there as well. Actually, as you know, we had already a few at SAP in the canteen and in the data space. So I can I'm sure we can make that happen somehow.
Perfect. Thanks very, very much.
All right. Thank you very much, Richard, and thank you everyone for joining. Really, really cool, and I'm already looking forward to the next one. Hopefully in person, but we'll see how long the current situation will go on. If not, we will definitely keep going, doing digital meetups, and I promise the technology will get better with every time. I'm learning a lot myself about how to do that, and I think that's also really cool. So thank you very much for joining, and see you all in the next one.